Hello and welcome to another DevOps learning session. My name is Prasanjit Singh and I'll be taking you through monitoring, metrics, logging, and alerts today. Okay, so what we will be doing today is about monitoring. Like whatever applications are deployed, they should be monitored, because if you don't monitor, you don't know the health of that service that has been deployed. Maybe you deployed something and after 5 minutes that process got killed, or it is very slow, or it is not working at all. So if you do not monitor, then you do not know what is the current status of the service. So that makes the application unusable. So in order to know the state, you have to monitor it. Now monitoring is done in multiple ways, so we will discuss about all that today. So first, what is the agenda that we have? The what's and whys of monitoring. So we'll understand why it is required, and what is the need of monitoring, and what are the various tools we use to observe. Then we'll understand how monitoring works in I mean nowadays how monitoring works, because there are lots of tools early on as well. Like it began with the monitoring using command line tools, and we still do that. So I'll demonstrate some of the old school ways also, but then we will focus more on how monitoring is done nowadays. So we'll know how it works, what are the various fundamentals that make monitoring work, and we will understand how to collect real-time statistics. Like if you get a data which is 5 or 10 minutes old, then that doesn't make much sense, because we are in a world which is very fast moving. For example, a site is down 10 minutes ago and now you got an alert on your mobile, or you saw some alert on a dashboard, but that is 5 minutes old data. Then that means your website or application has been down for 5 minutes. So you have lost a lot of customers who logged in the last 5 minutes, or were trying to reach the website in the last 5 minutes. So it is very important to get a real time statistics. You might have heard about tools like Nagios and all, but these are a bit old school nowadays. They work, no doubt. They let you do the monitoring part, but we need something very new and a real time statistics based monitoring, which has a very good dashboard, alerting system, and so on. So that's why we use some new age tools. So NetDATA is one of them, so we will work on that one. I'll demonstrate how to install and how to get it working on your systems. And most of the companies now have started adopting these tools, and in the future this will become a very widely used tool. So whatever is being adopted today and will become famous tomorrow, so you should start learning that. Existing things like Nagios is already there. There is another tool called Isinga. So these tools are already there. If you just Google about them, you will know how to install them and work on it. So we are not focusing on that. We are focusing on what a DevOps engineer would normally use. That is a bit two steps ahead of what others or normal system administrators are using around the world. So we'll understand how that tool works and how to get it installed and deployed in the system. Then we'll understand how logging works. Like whenever an application is running, it would throw errors, or sometimes warnings, or sometimes just information. Like application just started, so it should write somewhere in a log that the application started and at so and so time, and it is working perfectly fine. Say after 5 minutes there was some error on that application. For example, we open a website and sometimes we get errors like internal server error 500. There's a code and an error. Sometimes you open a page which does not exist and you see 404 page doesn't exist, and stuff like that. Or sometimes you get redirected to another page, that this page is not there, we are redirecting to somewhere else. So you get a code 301 and so on. There are lots of error codes, and error messages. So this logging helps us to know from the server side, like what happened at what time and what was the reason. So how that is managed in a huge high traffic web application. So you will understand and learn that, like how you manage logging normally. So all these most of the things in it would be handled by the developers, but as I always said, for a DevOps engineer you have to have an idea, I mean a high level idea of everything, whatever is going on, whatever the system admin does, whatever the developer does, whatever the tester does. So you are in a position where you know a bit of everything, and you help improve those processes. So we'll understand that logging, and there's a tool called ELK. We'll talk more about that, like what ELK stands for and what it does, how do these three components in EL and K, how they work together. Actually, these are three different components, so we'll talk about that. And we'll also discuss how do we monitor containers. By container I mean Docker. So uh, because normal tools will monitor a server, like you have a, say you are running a Windows system, or you have a server at home where you install Linux and install certain server applications like Apache or anything. And if you want to monitor it, you would use tools like Nagios or NetData. But for example, if you have 10 or 15 containers running, by container I mean Docker containers, so how will you monitor the health of each Docker container? So there are different tools for doing that. So we'll go through those tools. So this is what we are planning to do today. I hope that this will be over like within our time, around 2 hours. But just in case, because I do not want to skip anything or go out half-heartedly. So just in case the time doesn't permit, we will have another session and do that again. But I think this is quite doable in one session. So let's try and see what happens. All right. So first, what's monitoring? By definition, it is this, what you can see here on the screen, like it to observe the behavior of programs running in a production environment. Furthermore, it provides actionable alerts to identify and possibly alleviate problematic behavior. Now, this is definition. Don't go by that. Like, this is just for your interviews and all that stuff. So let me just tell you again, like what monitoring could be. As I said, whenever a software application runs and you see that it has run successfully, for example, you do a Docker run Apache or Docker run Nginx, anything you run it, and you see that the command did not throw any errors and it started fine. But how can you guarantee that after some time, like after say 5 minutes or 10 minutes, that application is still running? One cannot guarantee that unless one keeps a finger on the pulse of that application. For example, if it is still alive or dead or throwing errors or slow. So in order to know that, we have to watch that service, observe that service. So that process is called monitoring. Now this observation can be done in n number of ways. So here you can see some people can observe using dashboards and graphs. Some people observe using command line tools. Some people just tail the logs. In other places, there are probes. Like it depends on the situation. Like sometimes, say for example, someone is monitoring. Just don't confine yourself to understand that monitoring means monitoring a server. It can be anything. Like for example, if there is an earthquake going on, so how does that get monitored? There are probes all over the world from different weather stations, and they keep on monitoring whatever data comes in through that probe. Then we monitor, like for example, when you're driving your car and you have your dashboard filled with all the speedometers and how much fuel you have, so all these things. So anything that is measured, and when you are watching it and observing those measurements, so that process is monitoring. Okay, so even you might have seen, like when we pass toll gates in our car, then automatically amount of toll, that the toll tax is deducted. So how does that happen? Because there is a probe in your car, there is a probe on that toll gate. So as soon as you pass, there is a RFID transmitter that transmits your car details, and your account details, your balance is deducted from that. So the whole world now moves based on monitoring of applications. Like, monitoring is very important, and there are various ways to do it. Let me before we move forward, let me show you like some easy ways, like how monitoring is done. For example, let me then start one of the containers, and then I'll show you like simple monitoring, how it used to be in early days, like when these flashy tools were not there, shiny tools were not there. So how people used to monitor in those days. Okay, let me just check what is the IP address. Okay, 192.168.0.142. So we'll log in to that server, like that virtual box, through this SSH session, so that it will be easy for me to write the commands here. All right. So say for example, I want to monitor google.com is up or not. Just a simple, I want to probe that. So I can use a command like ping, and I write google.com. So I get a reply from that website. So that means that website is up. If that website was down, we would not get a reply. For example, if you uh, write something which doesn't exist, like if I add this doesn't exist, right? This is a wrong address. So it doesn't give any reply. So which means there's no such site, that means it's down. So you can monitor stuff using command line also. So you can monitor this, for example, I want to monitor what is the memory or CPU being used by this particular server. So I can use a command called top, and this command shows various processes that are running, how much memory and CPU is being used by that particular process, and which user is running that process. So we can see, say for example, there is a process called Docker running. It's using 3% CPU and so on. And so these are the ways people used to monitor earlier. There are lots of other commands. You can monitor your ports using commands like netstat. For example, I want to see which ports are listening. So here I can see the service name, and here I can see the ports. So DNS is listening on 53, SSH is listening on 22 port, and so on. So this way I could monitor. For example, I want to see the logs of a service uh, or logs of this server, what is going on behind the scenes. So I can run a command like this, tail. If you give a switch called -f, then you see a real-time logs, where log messages, or there are lots of logs. Syslog, it shows the system logs. So here you see the service had started and then the network went up, and whatever happened in the server continuously it keeps on pinging here, and you get your current state of the service, that this server is up, there was one particular request where there was an error, and so on. So this is how monitoring used to be, and it still is. Like if you want to debug something, sometimes you have to know a bit of commands. But nowadays times have changed. Like being DevOps engineers, we follow a concept of let me tell you a story about servers. Like earlier days, people used to have their servers, like there is a concept called pets and cattles. Okay, so let me explain what that is. In earlier days, people didn't have the concept of cloud. So whenever like now we just launch a server in the cloud, run our application, stop the server whenever we want, and start it again, and so on. But earlier people used to buy their own servers, have their own co-locations where they keep their servers, or sometimes on in their own offices, and they would even tag their servers, like name their servers, just like we name our pets and keep them with us. So similarly, they had their own servers, they would name them and deploy applications on those servers. So that's why you might have heard about supercomputers. Like when you read about computer science, you might have heard about UNIVAC, EDVAC, and so on. So each server had a name, and that was kept at a particular place, and it would run all the time. And if something happens to that server, they had to log into that server and fix the problem there. So this is the concept of pets. Like you have your server, something happens to the server, you have to fix that server. But now we run our servers and we call it the concept of cattles. Like for example, we run hundreds of servers, hundreds of Docker containers, thousands of, like a company like Google would have like a million containers running and hundreds of thousands of servers running. If you Google like how many servers that does Twitter have, or Google have, or Amazon have, then you will see there are hundreds of thousands of servers run by these companies. So is it possible like these servers would be named and tagged, and if something goes wrong with one server, a person would go and fix that? So that is not possible. If you have a million containers running, would you be able to log in? Like you saw, how did I SSH to this particular container? Now that was possible because it's just one container running and I know the IP address and I log in and fix something here. But imagine if I had a million containers running here, then could I go into that server, million servers, and run the same command or do something to fix it? So that is impossible. So nowadays the concept is to treat your uh, servers not as pets but as cattle. Like if something goes wrong, kill that, remove it, and run a new one. So a container goes down, you don't have time to fix that container. You just do Docker rm and remove it and run a new container. So that's how things have evolved. So monitoring has changed a bit. Like you don't want to fix that again. You create a new image and you run that image, kill the old one. But for that to happen, you have to monitor. You have to know whether the one which is running is healthy or unhealthy. So how do we go about doing that? That's what we are learning. All right. So now that brings us to this question, like how and why do we observe? So first of all, why do we observe? We have the answer to this question. We observe to know the health state of that particular service which we deployed, or the health state of the host server where our containers are running. So that is the reason like why we observe. And how do we observe? We observe using various new age tools. Okay, so we'll come to that in the forthcoming slides. Before that, I would just like to explain you this diagram on the left hand side. You can see waterfall and DevOps. In our previous sessions, we discussed that these are some of the models, like you have heard about software development lifecycle SDLC models. So waterfall is one of the models which was being used a long time ago. But when we bring it to the context of monitoring, what happens in waterfall model? What happens? You do each phase once, and once each phase completes, only then you move on to the next phase. For example, you are building a website. So first you start writing code, and that code gets completed in say 3 months time, and after that you test it for 1 month or half a month, and when the testing is over, then you deploy it to a server. Then that project is over. So that is how it used to work. Disadvantages: when the coding is going on, these guys are not doing anything, waiting for the code to come to them, then only the test will happen. So just enjoying and wasting time. So when this is happening, then the coders are doing nothing. So that was not a very efficient use of resources. So just imagine now the same thing when it works on a DevOps model. You do things in small iterations, like just DevOps follows the agile model and improves it by using CI/CD, continuous integration and deployment. So there what happens, a little bit of code is written, and there is a schedule of deploying that code, say every night. So that varies from company to company. Like there are, for example, Facebook does a weekly release. Okay, so they have a release candidate ready by Wednesday. You can read about, like, you might be thinking, how I know of it? I don't work for Facebook. But each company has their engineering blogs. So if you read them, you will know like how Netflix does their releases, how Facebook does their releases. So these articles are written by their engineers. So from that we also learn, like, and adopt the same things, because they are the leaders in the industry and so on. So how Facebook does that, they release weekly, and on Wednesday or Thursday they would really have a release candidate. For example, it's ready by Wednesday, then they would test it quickly and release on a Saturday or something like that. So every week they have a release. Some softwares have nightly releases, like every night they would release a new version, maybe a minor version, but whatever was done throughout the day would be released at night, and it would be tested by evening. So those pipelines would be running every day once, and so on, for the production environment. So in that case, you have a code gets tested, gets released. Next day again, code gets tested and released. So that way you have all these cycles going on every day. So no one is actually wasting time or doing nothing. So either they're doing something, or whenever they commit the code, they would be planning what to do next day, because next day again they have to code and release something. So that is how it works in this. So now, due to this engagement, like coding, testing, deploying, coding, testing, deploying, the engagement is more. That means more monitoring is required. Otherwise you don't know what happened to that code. Was it deployed perfectly? Was the test working fine, and so on. So if uh, you want this model to succeed, so monitoring is needed. So that is the answer to why monitoring is needed. So if someone asks you, as a DevOps, you would answer this, instead of just saying that uh, I mean, we know monitoring is needed to know the health of the application, the state of the application. But from a DevOps angle, you can say, like, since DevOps practice involves iterative deployment, By iterative deployment, we mean we do things in small iterations. Like I code, say 10 lines, and then I see whether it's working fine or not, and then I deploy. Instead of writing 100 lines for 3 months and then doing the deployment, every day, whatever is done, or every week, whatever is done, deploy it and go move ahead. So that's how it is done in DevOps way. So here monitoring is more important, because since you are deploying every day, and if something is wrong and you do not know and you deploy the next version again, and that error in the old version still remains, then it would cause a problem. So that's why monitoring is even more important nowadays. Next, how do we do that? Like monitoring is important, but how do we do that? So basically, there are three ways to do like monitoring or observation. Okay, just commit these three things to memory, like for interviews, for your own knowledge. Like monitoring can be done three. So these are also sometimes called pillars of monitoring and so on. So you can either monitor a application by its logs. You know what logs are. I was showing you the sys log. For example, that server started, it started writing different events to the log. So the log would be a like a diary. For example, you write a diary every day if you have that practice. I do not, but uh, we write like today's date and what we did in the morning and whatever happened. Some people record that. So log is something similar. The application itself writes whatever it does with a timestamp. So first it puts a timestamp and then it writes the event. Okay, so if you go back there, you see there's a timestamp here, date and time, server name. This is the event, like something in the network, this had this. So whatever event happens, it keeps on writing, and the time keeps on increasing. Like see, this is from 2039 and this is 2124. So whatever events has happened since then, it will keep on writing. If something else has come up, then it will again write. So it's still stuck here because nothing is new is happening in that server. If it faces some error or something new happens, then it will again start logging. So logs are output produced by the programs or the application and contain rich but unstructured and heterogeneous data. Okay, let me explain this part. It is a bit important because that is the reason we use tools like ELK. You might be thinking, okay, the server has logs here. So any application that runs would have its own log. For example, just like system log, for example, there is a web server running. So if you go to Apache, you will see some logs from Apache. So you see, Apache is also writing, this is the IP address from which a request came in at this time. What was the request on that server? Someone was trying the server name /test. So that page did not exist. So there was a 404 error. That person was opening the website from a Firefox browser and from a Mac OS, and see all these informations. So these are stored by the, you might be thinking that no one is watching you are opening a certain website, but if you look at this server side logs, you see those people have every information, like your IP address, the time when you checked, which site, what was the, it's not in a graphical way, but it gives every detail of whatever you have done in the journey when you access their website. So that is how logging helps to track every event and which are produced when that application is accessed. Now, what is this unstructured and heterogeneous data? Here, this log has some data there, like there are 10 or 20 events. This is one event. This is another event. Someone else opened the website. This is another event, and so on. Now sometimes, now this one looks like a homogeneous data because it is formatted well. Like first is the IP address, second is the time and date, third is the request, then the code, response code, then uh, the agent which was used to open that website, and so on. So this is a structured log, but this kind of log can be called an unstructured log because here sometimes this name is something, the response is not homogeneous, like it is not alike. So in these cases it is difficult to search these kind of logs and display it on a graphical form. So in order to take care of these kind of discrepancies, one would need some tools. So one of that tool is called ELK. ELK stands for Elasticsearch, Logstash, and Kibana. I'll talk more about it later, like when we go to this. So it is just a tool where you can push your logs and process them, and it would be easy to access the logs from that dashboard instead of accessing it from the server. So what is the need of having these kind of tools uh, to access your logs? There are other tools as well, like Splunk and Greylog. There are lots of tools actually to do the same thing. There might be around 20-25 tools to get logging done, but these three are the most famous ones. So since we are not going to do PhDs on these tools because we won't need it, whatever company will have, you have to start using it. As I said, all these tools, the fundamentals are the same. Like if you have used Splunk, you will find this one similar. If you have used this, you will find this and this similar. So mostly the fundamentals are same, but you learn one or two tools which are mostly being used, like which are most famous ones. So that is how it works. Like why do you use Windows, Windows 10 or whatever operating system, or why do you use Ubuntu Linux? There are hundreds of different other Linux operating systems. Or why do we use Android or iOS in our phones? There might be hundreds of other mobile operating systems, but we use the most famous ones because most people are using it. If something goes wrong, we can get it fixed easily, and so on. So similarly, we learn those tools which are mostly in use, and it's more likely that we will encounter this when we go to our next company. So either they would be using Splunk or ELK mostly, and some of them use Greylog. Okay, so learning one of them. So whichever I have made red, so that means we are going to learn that. Okay, and rest, it's there, but learning one of them is enough so that you can get a hold of rest of them. And later on, I have told you sometimes earlier, like I am also planning to create videos of all these tools separately, because in itself these are one, I mean, it's not like a one day thing to learn this entire thing. So it is in itself a different course. So I will keep creating videos, like 3-4 hour videos for ELK, and I'll later on put it on YouTube or something. So you can follow those. And I mean, when you get to a stage when you want to learn more about, I mean, you'll want to learn not more, learn everything about a particular tool, then you can watch that and go on. So I'll let you know when those things are done. But for this course, your objective is to learn various DevOps tools, learn the DevOps practices, and how to get started. So that is your aim now. So don't spend much time on one particular thing, so that way you lose your focus. So what I was saying is, when you have hundreds of servers like we have in companies nowadays, because it's just a matter of getting a cloud account, and they go and log in and launch say 50 servers, 100 servers. And we also have configuration management tools that makes us easier, like you go use Ansible or Terraform tools like that, and you provision 100 servers together. So that way you might be generating lots of logs. So 100 server will have 100 different applications on them, and each application has its own log. So how will you know which server went down, which is going up out of those 100? It's impossible to have a person looking at all those servers and quickly going into that server and checking the logs like this. So it's impossible. So these tools, what they do, they allow you to send your logs to that tool, and you can see from one dashboard what is going on. So that one dashboard will have hundreds of logs like coming in from different servers. So that way you have a single point where you log in and check the logs. So that makes it simple. So you can see all the logs from 100 servers at one place, and you can even filter those logs. Like you just want to see the errors, or you just want to see the 404. For example, you want to see how many pages got 404. So you can filter based on these fields and so on. So that's why these logs, like these tools, allow you to create a structured and homogeneous data, so that they can be easily filtered and parsed. By parsed, in software terminology, we mean that it can be read and understood. Okay, so that is what uh, logs do. Like, and these are the tools we use to read those logs at one place. So that is one tool of observation, like getting the logs to a software, something like this, and then going into the dashboard of that software and watch those logs, filter those logs, and see whatever events are going on. So that way we can identify which server went down, which server is having errors, or whatever, from one dashboard, instead of having to SSH and go into those 100 servers and check it. So that is about logs. Second is about traces. There is another thing which is important in monitoring, that is called tracing. Let me tell you what tracing is. For example, say a website is running, and it threw one error in the log, like you have some error like this. Okay, like a 404 error was there. Now you want to see why it happened, like what processes ran in the background that made this error to happen, which library failed in the software. Like, this is not normally needed by us, this is needed by the developers. So they would need you to have a tool that can do a tracing. Okay, so that is why we use this tracing part. Tracing is allows the developer to see which module of his program failed, and what are the different events that happened in the application that made it fail. Okay, so tracing allows you to get the series of events that happened to which eventually led to that failure. So that is not present in the logs like that. Logs will have the events, but they would have non-related events. For example, this event and this event are non-related, right? This is one user who came and checked and got a 404. This is another user who came and got a success. That means 200 code is a code for success. So these are all unrelated events, like independent events. But for example, if I want to know what happened to this user again, like he got a 404, maybe he came back again after some time and he got what did he get? I want to see that. So how will I trace that particular user? So that kind of thing is called a tracing. Like that kind of monitoring is called a tracing. All right. Then comes the metrics. Metric means the measurements. Okay, this is the real monitoring which we talk about. Okay, apart from the logs will have the events and whatever story happened, so that story will be captured in the logs. But metrics will tell you in numbers, like CPU. Here it would be written that server failed, or service has stopped or started, whatever, that would be on the logs. But why did it fail? That answer would be in the metrics. Metrics will show CPU had a spike of 90% or 100%, no more CPU resources were left, or the memory was completely used up, 88% of memory was used up by this particular service, rest of the services did not have sufficient memory, so that the website went slow or crashed or whatever. So metrics tell you that part of the story, the reason why something happened and was recorded in the logs. So logs will record the event, but metrics will have the numbers. Okay. So packaged or aggregate measurements. So this is what the metrics do. They collect the different measurements and put it on a time series. Time series means like when you are watching when you have a graph. Remember, in a graph you have two axes, x-axis and a y-axis. So for example, in one of the axis we put the time. So why do we do that? We want to see over time what happened. Like for example, at 10:30 there was one error, the CPU level was say 20%, but at 10:55 CPU was at 90%. So we can do a graph where on the y-axis we have the time, and on the x-axis we have the time, and on the y-axis we have CPU percentage. So that's how graphs and charts are done. So metrics is that representation of data. Okay, so that's how we do monitoring. Either we see those graphs or we see those logs. Okay, and tracing, as I said, it's rarely needed, only needed for debugging by the developers. So for that also we have certain tools to do that. All right, so now we will actually try to use these tools and learn how they work. Okay, so these are the things we actually discussed already. So you see, what are logs? They're the printf of monitoring. You might have heard about the command printf in shell scripts. It's also in C programming, in Python also. So printf means whatever is happening, that is echoed or printed on the logs. So for monitoring, the logs tell you the story. So they print the story of the events. So you can see that on the dashboard if you are using tools like ELK or Splunk. So you will get a dashboard like this where you have that data. So you can see this is also a data from a web server. It's very small, I mean this diagram, but I can see this is a web server data. See, here is the IP address, then the date, time, and then the website response code and so on. So this is how it will look like when it comes to a dashboard, instead of like this when we were watching it from the terminal. All right, so logs allow you to watch that, and logs can be viewed in a number of ways, like tailf. This one I already showed you. So this way in a dashboard, and sometimes logs can be put into can be sent as Slack alerts and so on. So I'll demonstrate these things to you in a while. Then comes the metrics. We already discussed like what metrics are. So how will metrics be shown to the users? So metrics are shown to the users on dashboards, and there are various charts configured on the dashboard so that the metrics are easily visible. So that's about how the metrics works and so on. So it says the metrics is the report card of monitoring. So it's just where at one glance you know what's going on. So that is what metrics are. In logs you cannot say at one glance because you have to read all the lines and then know something happened. But in metrics you have graphs. If you see a surge in the graph, like it's going up, spiking up, then you know something is being used up too much. If it is going down, you know something is not being used that much. If it is completely not appearing, that means maybe the data is not coming up, or that server is down. That's why there is no graph. You might have seen the lifeline going on in hospitals, so that is also a monitoring metric, right? If there is a straight line, means dead, and if something is moving, that means uh, metrics are coming in, so that guy is alive, and so on. So similarly for servers it's the same, like CPU is going up and down, that means the server is running, processes are running. If it is going too up, then which process is causing that particular CPU to spike, so you will have to monitor and find out, and so on. So this is what happens when you want to monitor using metrics and you use those dashboards. Now there are multiple ways, like how do those dashboards work? I think this is the last slide where we'll discuss about the theory and all, and then we'll do it, then you will actually understand more like what I am telling now. But just try try to understand as much as you can right now. But when you will do it in action, then you will understand much better. So there are for example, if I have a dashboard which is showing me metrics, or if I have a dashboard which is showing me the logs, so how is that working actually? Like for example, you have 100 servers and you have one dashboard somewhere which is showing the data of that 100 servers. Like you want to see the CPU of those servers, it is showing a graph here. So how is it working actually? Okay, so behind the scenes there are multiple ways in which the monitoring systems work. Okay, the most popular way is this one. This one, publish, subscribe. In computer science terminology we call it pub sub. You might hear this term when you, I mean, start working. You will hear this a lot, like it is working in a pub sub way, check whether the pub sub is failing or not, something like that. So what does that sub mean? There you have 100 servers which are to be monitored, and here you have one server which has the dashboard. Okay, just imagine this scenario, like you have 100 servers, like here you have 3 servers, and you have one server where you are monitoring it. Okay, and that server shows the dashboards and the statistics and so on. So now these servers have one component called an agent. So that agent is installed in these servers. It's just a small application. Okay, so now this agent sends data all the time. Whatever is happening here, it is sending to the monitoring server. So all 3 of them are sending. So if you have 100 servers like this, those all 100 would be sending data to this monitor. Okay, now this monitor will then process that data and change it into graphs and everything and show it on the dashboard. So this method is called pub/sub. Why? These guys have an agent which publishes the data. Like it takes the data and publishes it to this one. Now this guy is subscribing to different servers. Like there might be some the 100 servers which send it to this particular the subscriber. There might be another monitoring dashboard where some other servers are sending, like for example this is the billing department, so all the servers of billing are sending to this dashboard. There might be a finance department that has 5 servers, so those 5 servers are sending data to some other dashboard. So that is the subscriber for these 3 servers. So those 5 servers from the finance have different subscriber. So this one who is receiving the data is called the subscriber, and who is sending the data is called the publisher. So the agent is publishing and subscriber is subscribing to it. Like, it is subscribed to these agents, so it is getting data from these agents and rendering it on the dashboard. So these steps are written, like how it happens. Agent collects information from servers and publishes to a centralized store. The monitor broadcasts the events, and then the subscribers receive the events and they show it on the dashboard. So this is how this one works. So this is the most popular way of monitoring. Like, you have number of servers, and in each server you have the agents there. Those who have heard of Nagios, you might have heard about this. Like, when you have a Nagios dashboard, you have some agents also installed, and that agents, like SNMP agent or something like that, that agent sends data from each of the server to the Nagios dashboard, and then it displays. So this is a way of doing it. But now there is a bit more advanced way that is called telemetry. Telemetry is a way in which data is collected from instruments, and these instruments automatically transmit the data. Like I was talking about that toll tax thing. Like, there is a RFID transmitter, and as soon as your car reaches the toll gate, it automatically knows what is your vehicle number and how much balance is there in your card, and it automatically deducts the amount of the toll tax. Or for example, when we go into the offices where we have our access cards, and we touch the card to the receiver that is there in the door, and the door opens and your attendance is done as well. So that kind of transmission is called telemetry. Like, the device itself has some code in it that it transmits that to the other device, and the other device can monitor and know that this guy has come in at this time, and that particular event is recorded. So that is called telemetry. So nowadays, lots of applications, like whatever software applications are being written, they do their own telemetry. So agents are not needed anymore separately. Okay. But not every application. That's why you should still know about pub subsystem. Telemetry happens in most modern applications nowadays. You might have even seen in your mobile phones, like, you install an app, and sometimes that app is sending some information to its original server. Like, that app crashes and you get a pop-up, like, there is a crash happened, I want to send the crash report. Do you agree? If you say yes, it will send that crash report to its mother company. So that is telemetry. Like, that instrument has an application that automatically works like an agent and sends it to the mothership. So that's how uh, telemetry works. So you don't need a separate agent running on that server. That's application itself will send it. Then there is another way of monitoring called health check. Like, uh, if you have gone through the previous some of the CI/CD videos, you will see we installed an application called Spring Boot Java application. So those kind of web applications have a health check page. Like, for example, when you install that website and you go to that website slash health check, like, for example, if the website is google.com, you write google.com slash health or something like that. So when you go to that page is called the health check endpoint. So that page does a analysis of its own health. Like, the application will check how healthy I am, and then it publishes the response there on that page. That server is healthy, uh, whatever different metrics it wants to show, it can display there. So that way, You don't need any agent or anything. You can just hit that endpoint and see it is healthy or not and what are the metrics. So that is also a way of monitoring. Like you just go to the health check page and see what's the metric is for that particular server. And there is another way of doing monitoring that is called data warehouse. So the ELK I was saying uses this format. Like here you have different agents that push the logs to a database called Elasticsearch, and from that database you can search different events and display it on the dashboard. So this part will not make much sense to you now. So when we do this ELK, you will see for yourself, and then you can ask me the question. So I'm not elaborating this one now, like, because now if I keep on saying like data warehouse and pushing of logs and Elasticsearch and Kibana, it won't make much sense to you. Let's install that and then we'll talk more about this one. Rest of the things at least you will understand. Like you have agents that push the data from each server. So if you have 100 servers, you have 100 agents installed. So they will tell their own story to the subscriber, and subscriber will use that story to put up a graph in the database, in the dashboard. Telemetry also same. You don't need a separate agent. That particular instrument will automatically transmit its own health state. Here it will not transmit anywhere, but it will show in a separate page about its health. So if you go to that page, you can know what is the health of that entire application. So these are the different ways in which monitoring works. So now let's get started with doing something, and we will see how it works. So first we'll try out a metric based monitoring tool. Okay, so NETDATA, as I said, is one of the most upcoming monitoring tool. So whenever if you start working somewhere, always suggest like try to install this tool, because this is very new age and gives you a lot of information, unlike Nagios or old school tools which have limited information. Like there are other tools called Munin, Monit, Nagios, these kind of tools. They have been in use for around 20 years now. So they are good, they do their work, but the difficulty in getting them installed and having the dependencies in place and the look and feel, everything, I mean, is not something which you would like to do in 2020. Like it would look like a tool from 2005 or something like that. So NetData is something which is becoming very popular, and it is very easy to install also. So that's the reason, and reliable too. So that's the reason we are doing this tool. All right. So let me then try to install NetData. Okay, before that, let me also show you one more thing. All right, so we are here now. So once we do NetData, we'll do ELK and Prometheus. So let's see. All right, you also go to this notes, to this repo. I think you should have the link, or I'll share it again. And then I think I had this notes here. Yes, there's this note for this particular session, monitoring logging. So here you have the definitions and different important terms, like what does it mean, telemetry, and different terms that are used in monitoring. We discussed all this actually. What is logging, what is tracing, what are metrics, and so on. So for the hands-on, whatever commands we are using and all that stuff, it is here. So you can directly use these commands from here and refer this document to do your installations and other things. Okay, and also whenever there is some other repository that contains the demonstration, so that link is also there. So I have updated it, and you can use this. All right, so what is NetData? As I said, it is a monitoring agent designed to run on all your systems. Like it can run, that's why I said like this one is very good. Why? Because it can run on Windows as a Docker container. It can run on Linux, BSD, Mac. It can monitor Kubernetes and whatever is there in the industry right now. So NetData can monitor all those stuff. So that way it is very valuable and useful. And over on the top of it, it is very easy to install because the installer is just a single line installer. Okay, so you just have one command and you run it and install it. Okay, and there are two options for it. Like if this command doesn't work or something is failing, then don't worry, you can just run this command and it will run a Docker container, and NetData can work from a Docker container as well. So you have two options. So don't run both of them, then it will fail. Why? Because a dashboard runs on a particular port. So if you run this and it's running already, then if you run it as a container and it tries to run on the same port, it will fail. So only you run it as a container only if this command has some errors in your Linux version. Because see, they keep on updating the scripts and everything, because you can see they have nightly updates, so every night they release the fixes. But things are always changing in the software world. Say Ubuntu 18 has a new release and that release doesn't match with this particular NetData and it doesn't get installed and so on. So in those cases you can use a Docker container, this command, to run it. Okay, so let's try this one and see whether it gets installed or not. If it doesn't or has some errors, we'll install it this way. So it's just a matter of which one to do. So it doesn't matter this is better or the other one. So you can try any one of them, whichever works for you. Okay. So we have this server and our IP address is 192.168. Man, this one is disturbing. This is our IP address of that server, right? So we will install and we will see it here. So this is the command which you have to use to install it. So straight away just copy and paste it here. What it does, let me explain. This command goes to this particular website of NetData and downloads a script. Kickstart.sh is a shell script, and it installs that script into the shell. Bash is the name of the shell in Linux. So it installs this script. Now this script contains the information about the installation. So just like in Windows, you download a software and install it by running that wizard. So similarly here you are just installing it by running this script. So you just copy paste this command and it will try to download and install it. So it is checking for different libraries and whether something is present or not, and asking us to press enter to run. So we say yes, enter. So it will download the libraries and install it. Now it is again asking us question like, do you want to continue? These are the packages that are going to be installed. So we say yes, and it will install those packages. Now if this process goes fine, then we will have a running NetData dashboard. So that is how NetData will be installed in the servers. Now, while this is installing, let me tell you, you might be thinking like, if I have 100 servers or 1,000 servers, so how will I install NetData on them? Will I have to run this command 100 times or 1,000 times on 1,000 servers? So the answer to that will come on the next session when we do Ansible. Like you don't have to do 1,000 things on 1,000 servers. So you have to you have some tools like Ansible which you can use to run this together. Like for example, if you want to run this dashboard on 100 servers or 1000 servers, you can use Ansible or Puppet to run it together. So we'll do that in the next session. So there are actually lots of things. So that's why even after this course, you have to spend around 2-3 months to finally be confident of what is being taught, and then only move forward. Like, if just don't hurry on this. All right, so all done, we are proceeding to the next step. So all the libraries are done, and now if we press enter, it will start building the NetData dashboard. So we press enter. So now the compilation is happening, like different libraries are compiled and then installed. So that process is going on. So normally we don't have to do anything other than just say yes here. Similar to what we do in a wizard installation in Windows. You just have to do next, next, and finish. So it's just like that. But in between, if there is some errors, then there is not much you can do to fix it, because this is all being built from C libraries. So the program is written in C and we are trying to build it. So if some problem happens here on your particular box, then go ahead with the next command. That's why I included this Docker one. So you can run it this way also. And NetData is very lightweight. It uses only 64 MB of memory. So this is also another reason why this one is popular. Like other monitoring tools, like Nagios and all, they still need more memory than what NetData does. So this one will take around 1 minute. And one more thing while this is getting installed, like today we are going to do NetData, ELK, and there is something called Prometheus and Grafana. So these are the different tools we'll do. But these are not tools to be learned in one day. Okay. So uh, when you watch this video and try doing it, do one at a time. Like, there's no need for you to finish all that in 2 hours and then say this course is over. For you, you can install NetData, spend the rest of the day mm, going through the dashboard and learning what is there in the dashboard, what are the different metrics there, what you can monitor, playing around with that thing. Like, run something on the server and see whether there is a spike on the CPU and memory or not while you are running that program there. So things like that. I'll show you one or two things. But what I'm saying is, spend this some time with this tool, and then next day install ELK and watch the video from where we have started installing ELK. So watch that part and install ELK, navigate around and play around with that tool so that you know what is there inside out. So we are doing it for the sake of finishing the session of monitoring, and there are 3 different tools which we are going to cover, so I'm covering it. But for you, you are the learner, so you will spend some more time on it instead of just getting it installed. And because the lesser time you spend on a tool, you will forget it very fast. But once you start working, then I would not say anything to you. Why? Because there you would be using the same thing in your office every day. So then you don't need to practice, but for now you will have to spend some time so that it becomes a second nature for you, like using these tools. Okay, so it's still going on. You can see these steps, like dashboard is getting installed, something even failed. All right, so it's done successfully. Okay, let me tell you something about that failure. See, whenever these applications get installed, sometimes there might be certain failures. So that doesn't mean your installation is broken. If that failure is that critical that it would not allow that monitoring tool to work, then it will fail the final, like in the final place, you would not see a okay, you will see a failure. But here there was a test case failure for this kernel collector. So there was a metric which collects the information of the kernel, and that was not supported with Ubuntu kernel. So that particular thing failed. That doesn't mean that this dashboard will not work. Okay, so if there is a failure that is critical, then automatically in the end it will say it will say failed, and it won't say enjoy your performance or anything. It will say that installation has failed, try again with this library that is missing. Okay, so from that we know that we have successfully installed it. All right, so we are good. Then how do we see that installation? Let's go to the browser. NetData is available on this port 19999. All right, this is the default port where NetData comes. Now slowly data will start coming in, and you can see the real-time data of the NetData dashboard. All right, so here you go. Now the data has started coming in. So here you see different metrics. That's what I was saying, like spend some time over it. See, CPU is coming here. Then here you get network, like how much inbound traffic is coming, how much outbound is going, memory, read write in the disk, whatever CPU is being used, and so on. Okay. So this is more granular level of how much RAM is being used. From here you can see 17% of RAM is being used, but here you see a breakdown of that. Like system is using this much, cache is using this much, and the green one is how much it is free. So these are the various monitoring parameters. So when we monitor this, we can know the health of a server. For example, if the load is high, the CPU will be towards 100%, or the memory will be towards 100%. So now we see there is not much load on this server. Okay, let this be running. While we do the other operations, the load should increase. Now you see 2% CPU. So now, for example, let's move on with ELK or something else. So while we install that on the same server, you will see this one increases. So that way you can also see whether this is working fine or not. Okay. So this is the dashboard. You can monitor it this way. So Linux server 01, whatever is the host name, and this is the dashboard with various metrics. You wouldn't even need all the metrics. Normally we need the CPU, the memory, the network, and the disks. Okay, like whether the disk is full or not, how much empty space is left in the disk, and so on. So this is how you set up a monitoring tool. All right, so you just write that command. If it doesn't work, then you use the Docker. So these are the new age monitoring tools which make things, simpler for you to maintain. If something goes wrong, you're not going to fix this tool. Instead, you are going to uninstall this and install again. Okay, unlike Nagios and all those tools where you have to go and fix that particular tool. So here it gives you the independence of just removing it and then reinstalling, because it doesn't affect with any data that is stored in the system. So you can remove it and again reinstall it, brings back everything. So these are the kind of tools that help you to monitor using a dashboard. Also, this tool has a alerting feature. If you click here, you get, if you click on all, you get this. Okay, so here it says you can even set up the alerts. These are the alerts which are set up. So it will alert your Slack channel and other these kind of alerting setups. So that can also be configured using NetData. All right, so I'll show you how alert will be configured towards the end. So let me first go through the next one, that is the ELK. Okay, then we do the Prometheus Grafana, and there we will do the alerting to Slack also. All right, so I think NetData you can easily install like using this command. Doesn't work, then use this command. If you want to uninstall, just, there are 3 commands. So you download this, then run this command, and then this. So these 3 commands will allow you to uninstall if you want to remove NetData. But now I am not removing, because I want to show you whether this one increased or not when we were doing the installation of ELK, because ELK will take some resources to get installed. So we will monitor it at that time as well. Okay, so before we move on to ELK, let me tell you something about ELK. So ELK stack stands for, why we call it a stack, first let me tell you, because it uses 3 different softwares: Elasticsearch, Logstash, and Kibana. These 3 are different softwares. Okay, but we use them together to get the logging done, to collect the logs and to display the logs. Okay, so Logstash is the agent that collects the logs from those different servers. Like you have 100 different servers with 100 logs. So there is an agent that collects the logs and pushes it to a database called Elasticsearch. So Logstash collects the logs from different servers and pushes it to the Elasticsearch database. And Kibana is a dashboard which allows you to watch the contents of the database. Okay, so Kibana is the dashboard, Elasticsearch is the backend database, Logstash is the agent. So if you have 100 servers, you will have 100 Logstash agents installed in all those 100 servers. So these agents will collect the logs and push it to Elasticsearch database. So now 100 logs come to one place. Okay, but you cannot see them yet, because the database will have it in its own tables. You cannot see it. So if you want to see it on a dashboard, so you have to install another tool called Kibana. So Kibana is a tool which gives you a dashboard to view the logs which are present in the Elasticsearch. Hope you could understand like this flow. Log will be collected by Logstash, sent to Elasticsearch. The name is a bit misleading. Search doesn't mean you're searching or something. It is a database. Why we call it Elasticsearch? Because it is a very powerful search engine also. Like when the data is there, you have a very good query language which you can use to search the data and filter that data. Okay, so basically it is a DB, file DB. Like you can just copy the log files and push it there, so you have all the files at one place and you can index it there, and using those indexes Kibana can display it on the dashboard. By indexing, if you read more about databases, you'll understand more. You can just imagine, by indexing I mean you have a book and that doesn't have an index page. Index page refers to the contents page. So there I know the name of the chapter and the page number. So I want I want to read something about thermodynamics. So I go to the chapter thermodynamics, page 532. So I directly go there. So if I didn't have that contents page, doesn't mean I will not find that thermodynamics chapter, but I will have to flip through the book many times and then suddenly I find that. Okay, so it's similar when you are viewing a log in a dashboard. If I do not know where that log is and from which server it came and all those information, then it will take more time to search a particular event in the log. So if it is properly indexed and arranged, then the search becomes faster and it is easy to visualize that particular event. Okay, so all these things happen by these tools, and these are different tools, but since they are used together to view the logs, they are called a stack of tool. It's a tool stack. So ELK is a stack where you have to install all these three and configure them so that they work together. So now how to do that? Let's do that and see. All right, let's see for ourselves. So definition and all, you can go through these notes because I already explained like what those three things are and what they do, how they work in tandem. So this is another repository where I have put up a demo of the ELK. So you will see the ELK in action. So what I'm going to do here is, let me just explain. I'm going to install Elasticsearch, Logstash and Kibana, all the three. And then how do I like I have these three, so I have a dashboard, I have a database and I have an agent, but that where do I get the logs from? So for that I am also running a Spring Boot container, like Java Spring Boot, the same one which we deployed using the CI/CD pipeline. So I am running that Spring Boot container and we will do some events on that container. Like we will hit its the container URL with a user ID or something, and when that event happens we should see the logs on the Kibana dashboard. Okay, so this is what we are going to do. First we will install the ELK, then we will run the Spring Boot application, and then we will uh, check whether the logs are coming in for the Spring Boot application or not. Okay, so to simplify these steps, I have the steps written here, but in order to deploy everything together, we use something called Docker Compose. Docker Compose is nothing but a script which has all the components written together. So for ELK, this is the Docker Compose. So when you need to install a ELK, you can just copy this thing and run it on your server. Like even if you are doing for your company, you can use it this way. So you will be able to run a ELK stack in a few minutes. You can get it up, and then it uses volume, so your data will also be persistent, and it will be very useful for you to work. Okay, yeah, I mean work with ELK easily. So I have this Docker Compose script here. So what does Docker Compose do? Just like we run Docker containers using Docker run and then the container name. So if we have multiple containers which have to work together, just like ELK is, so you can use a script called Docker Compose, where you have mentioned everything like what you want to run. You want to run Elasticsearch, your container name should be this, your image name, your build name should be this, which images will be pulled, and so on. So this way you can run your multiple containers together. Okay. So first is we have to clone this repo, then inside it we have to do some prerequisites, and then we run this command to bring the ALK stack up. All right. So let's do that. So first we have to clone this repository. So you just copy it. Git clone will clone the contents of this repository to the server. Okay, let me create a folder here just to not to mess up with other code we have kept here. There are lots of things here. So I'm just creating a separate folder called monitoring, and inside it we'll do our thing. So I entered that folder monitoring. So here I'll clone. Git clone that IP, the URL of the repository. So it has pulled all the code from the repository. So here you can see ELK stack demo. That's the code. So here we are. That Docker Compose file and everything is here. Okay. So the next command is a prerequisite that has to be set. Without this, it fails. Now, this setting is normally present in cloud servers. So if you do it in Amazon and all, it won't be needed. But still, you can run it. There is no harm running this command. So this actually increases a parameter in the kernel of the operating system. This parameter is needed to needed for Elasticsearch to work properly. So that's why we have to run this. If you do not set this, then your application will run, but Elasticsearch will not work and it will go down. Okay, after 2-3 minutes, it went down. Actually, I learned it the hard way. I was trying it few days ago, so I was seeing that Elasticsearch used to go down after 2-3 minutes of running. So then I followed the logs and I found that in the log it was written VM max map count is too low. So then I googled about it, like what VM max map count for ELK. Then I found that it should be set at this number. So, and this is the command that should be run. So that's how we fix the issues actually. No one knows everything. Even I don't claim that, because even when I did it on my organization, I never faced that issue. But when I did it on a virtual box, I saw this error. So then I learned, okay, when you do it on a virtual box, this is a prerequisite. When you do it on a cloud, you would not need it. But still, if the same error comes, we can run it. There is no harm on running the command. So you run this command and it sets that max count limit to 26 lakhs, whatever. So this is the prerequisite done. And one more is Docker should be obviously installed, because without Docker, these commands will not run. And Docker Compose should be installed. Okay. So how to install Docker and Docker Compose? Then Ubuntu apt install docker.io. This is for Docker. I have already shown you earlier. And Docker Compose. So this will install Docker Compose. So these two are prerequisites to install the rest of the things. So then Docker Compose build. Run this command. It will take a while and build. It is downloading various dependencies from the Maven repo. Why this is happening? Because I told you, apart from ELK, I will install a Java Spring Boot application. So whenever you install a Java application, Java uses Maven as a build tool to build the artifacts. Okay. So by artifact, I mean the jar file. Whenever you compile Java, it becomes a jar file. So that is built by using dependencies from the Maven repository, and the build tool is called Maven. So that process is going on now. Like it is taking the Java code, bringing the dependencies from outside, downloading them, and building this jar. So once that jar is built, it will build the Docker image of that Spring Boot container. Once that Docker image is built, it will run all the Docker images of Elasticsearch, Logstash, and Kibana and that Spring Boot app together using that Docker Compose file. So once Docker Compose has been run, we will have all the servers up, and then we can see the logs and all in our dashboard. Okay. So let's get there and then we'll see. So this will again take some time because it's downloading a lot of things. If you were doing it on a server, like on a cloud server, then it will take very less time to do it. Okay. So let's see. Let's go through the commands. Meanwhile, this is getting built. So I'll explain a bit more on the commands. Docker Compose build. This step builds the images of the containers that are written inside the Docker Compose file. So Docker Compose file has which containers written? One is the app. This is the Spring Boot app, Elasticsearch, Logstash, and Kibana. So all these four things are getting built now. So once the Docker images of these four are built, then we will run the command docker compose up. So this will up the four servers, like four containers. So once we have them up, then we will be able to see the dashboard, and the Spring Boot app will be up. So we will be able to access this URL, and that will create a log on the server. Okay. And if we make some mistake while hitting the URL, that error should also be logged. So that is the thing we have to verify. Like if there is some mistake, the error is getting logged or not on the ELK, and whether we are able to see the log in the dashboard or not. So these are the things we have to verify, and we'll also see how the dashboard looks like and how to operate with the dashboard. I'll show you a few things like how to filter the data and how to look at that data. Okay, so let's go back. All right, so that build was successful, and then all the other containers were built successfully. Okay, and this build time depends upon the speed of your internet connection, your speed of your server. Since we are doing it on VirtualBox and on the same laptop, I am running so many things. So that's why it might be a bit slow, like it took a bit of time. But if you do it on an Amazon server or something, then it will be faster. Okay, so now Docker compose up. This will bring up all the ELK stack, and minus D stands for daemon mode. So I want this one to run as a daemon in the background. So it will become a background process so that it doesn't interfere in the screen. So you can see Elasticsearch is up, Kibana is up, Logstash is up, and that demo app is up. Okay. So we have everything running. So let's go and see whether the ELK works or not. Okay, meanwhile, let me show you in NetData. You see how much CPU is getting used, 100%. Why is that? Because so many containers are running. If you do a Docker PS, 4 containers are running together. So they're using a lot of CPU and memory. So 100% of that is getting used up because this is a very small server. Like it's inside my laptop, there's a VM. Inside that VM, we have these things running. These need a bit of more memory and CPU. And we have lots of processes running in the laptop as well. So that's the reason you are getting 100% CPU there. But this validates the dashboard. Like your CPU is your dashboard is working fine. It is recording everything properly. Okay. And it gives us one more insight also. Like this ELK stack is a CPU intensive application. Okay, because most of the times the CPU being used is much more. RAM, at least it still has 10% RAM left, and I have only 2 gigs of RAM in this VBox. So it's still manageable that it is using less than 2 GBs of RAM. So that's fine because servers would have 16 or 32 gigs of memory. So this is a concern because the CPU is being used of 100%, so everything else might get slow. So that's how people can monitor and understand what is whether the application is CPU specific or memory specific. So what you should increase when you have a slowness. So if someone asks me to speed up this application, I will not add more memory, I will add more CPU cores. Okay, so I will use a 4-core server or 8-core server or 16-core server so that it will become very fast. So that is how people monitor and decide like what happened. Okay, and here you can also see alerts. Like these are about alerts. Like yellow, there was one alert, and there is one red alert. So here you can see there was one alert about the memory and one alert about the available memory. Maybe there was a spike of memory once, so that came in. Some logs are also visible here. Okay, so that was about the NetData thing. So we are already past that. So now we are doing the ELK. So I was just showing you just to display like how the resources are being consumed on a real-time basis. So here, whatever you are seeing, it's the current, like to the moment data. Okay, there's no delay, just it's a real-time data. So we began our containers 2 minutes ago at 2:58. So at 3:1 we are here. So if you wait for a while, you can see this moving forward. So it would refresh every 5 seconds or so in order to show up new data. Okay, let's go back to the ELK. So the server IP is same, whichever server we are running on. So the IP is this one, 0.142. And let's see what port this one is running on, ELK. So I told you Kibana is the dashboard. So we don't need to access the rest of the stuff. They are backend stuff. So dashboard is where we will go. So Kibana is this image. It is listening on 5601 port. Okay. So everything is getting recorded, don't worry. Like, you, once you watch this video, you will be able to follow it, pause it, and then do the thing when you are practicing. So no need to worry that you will forget the port or something. Okay, so that's why I'm showing you like how you will find out. If you forgot the port, write docker ps, you will see all the images running. Find Kibana, find the port, then put up the IP address, the port, and run it. So it will load the Kibana dashboard. It might take a while because already we saw our server is having 100% CPU usage. So once the Kibana is up, we will try out that application and see what happens. All right, so we have this Kibana dashboard coming up, but there is nothing being shown yet. We don't see any logs or anything. So this is normal, no need to worry. Whenever you install Kibana for the first time only you will see this page, okay? Otherwise it will directly take you to the dashboard, okay? So first time you will see this page and it says that it is unable to fetch mapping, that there is no index. So if you want to create an index, you will have to write the name of the index. So index can be anything you can give, like web server.star or something. So whatever is default, you just keep it like that. But here a drop down should become active once the logs start coming. Okay. So now it is not active. So I cannot create the index now. So the log should start coming for the index to be created. All right. So how do we do that? For that to happen, you have to open the application and hit that application. Like, you have to run something on the application. Only then the logs will be sent to Kibana, and only then the Kibana dashboard will become active. So I have written that step also here. After Docker Compose, everything is up. Next is to consume the Spring Boot app. You can either run this command or you can directly browse it here. So what I will do is, so instead of localhost, I will put that IP address. Okay. So that application is running on 8080 port and user, and then you can give any number. So let's see. So it will be 192.142. This is 8080. So let's see what happens if I go to that app. It shows an error because there is nothing there directly. If I run health, I can see the health check says up. So that means the Spring Boot application is running. I told you there is some application which shows its own health check. It does not need an agent. So some of the services like this one, Spring Boot applications, have a health check page. So that shows the health. But that's a different story. So we are going to ELK. So we are going to generate some logs, only then it will work. So to generate the logs, the manual says just go to the port/user, put any user ID. So I just put 123.123, anything you can put. So it says that, okay, this is some dummy application. So it gives you a response. So that means that event has worked. Let's put something which is not a number. So it will also throw an error. Test 000. So it shows an error because it only wanted a user ID to be a number. So if I say 122.122, again it's working fine. So we generated some events here. Like whatever we did, that should already be going to the logs, because logs take care of the errors and the events. So we just hit the URL couple of times. sometimes with a correct value, sometimes with a wrong value. We wrote this is not a user ID, so it will again have error, and so on. So now these should have gone to the Kibana. So once you have these things in the Kibana, it will open up the index. So if you refresh the page, you can see now the drop down has come. Okay, so once you see the drop down, select timestamp, because we need a timestamp against each event. If you choose this, it will only show the date, but I want the date and time. If you choose this, it will not show any date and time, only the event. But don't do this ever, because without date and time, the log server doesn't have any sense. Like, it doesn't make sense. If someone asks you when did it go down, you don't have a time for that. You just know that it went down, or you just know that an error had happened. So that's a problem. You need a timestamp for every event. So that's why we choose a timestamp here. And I'm telling you, this is only a one-time task for the first time when you're installing. Next day, if you go and log into Kibana, you won't see this error. So rest two checkboxes, nothing to do here. These are deprecated options like old and discarded. So just these two, create index. So it has created some index on its own. Don't have to do anything here. Click on discover. So here you can see the logs have started to come. And in the logs you have date, time, and different stuff. Okay, different information. Now if we keep on hitting these kind of URLs, errors and events, you will see more logs coming in. It will take 1 or 2 minutes. If you refresh the page, see two more events have come in. Okay, so there were 4 events earlier, so one more event has come in. Now how do we see the data here? Like, how do we arrange it? So you can do it in many ways. Like, first of all, you can segregate what fields you want to see. For example, I want to see date is already there, but I want to segregate this part a bit. So I want to see the error, the level of the error. Okay, so I click add there. I want to see what was the message. So I can add that. Like, if there was something on that message, what is the message ID? Date is already there, no need to do anything. This is not needed. And so on. So this way you can define what you want to see and what you don't want to see, which IP that request came from. All right, so these on the left hand side, whatever fields are there, you can use them to segregate your logs, okay, and filter your logs. Yeah, all right. And there is one more thing, so let's cover this one and then we'll conclude. So this is about the logging part, and now we come to Prometheus and Grafana. So the names are very strange, you might be feeling, but after a few years of using them, it becomes like very normal for you. So Prometheus and Grafana, what are these? These are also similar to NetData, but why I'm covering this, I could have told you like NetData will do, it's very easy and the easiest of all. So you could use them to monitor everything. But this one is very famous actually. So there is a possibility like wherever you start working as a DevOps, you will find this tool, Prometheus and Grafana. These are even two different things. Prometheus is the agent that collects the data and Grafana is the dashboard. Okay. So that's why you should have a bit of idea for about these tools also. Okay. And one more advantage is these tools allow you to monitor the Docker instances. So if you look at uh, NetData, NetData doesn't allow you to monitor the Docker instances. It is monitoring the host server. What is it monitoring? Linux server 01. Is it monitoring what is inside Linux server 01? Like ELK is running inside. Do you see anything related to ELK? You see the total RAM and CPU used on that server, but not how much Elasticsearch is using. If someone asks you how much Elasticsearch is using or how much Kibana is using, so you cannot monitor individual Docker containers here in NetData. So that's the disadvantage here. So Prometheus and Grafana take care of that part. Like they monitor the entire stack. So that allows you to know how much each container is consuming. All right. So let's move ahead with doing that, installing and using it. So that one is also having a repository. I have a link here. So this particular repo contains the steps to install Prometheus Grafana. Very easy, like only these two commands, these three commands will get you a Prometheus plus Grafana installer. However, let me do one thing before we get started. I'm going to remove the ELK stack. Why I'm doing this? Because if it is already using 100% of the CPU and we start running Prometheus, then it will die. Like it will not work at all. It will be very slow. But if it is a production server, like 16 gigs of RAM or something like that, and 4-core CPU, then all these applications will start working. Because you are working on your own virtual box, you have to be a bit frugal on that part. So how do I remove a Docker Compose launched setup? So Docker Compose, there are multiple ways actually. So you can do it this way, Docker Compose stop. You can also do Docker Compose down. That also stops and removes. Then if I do Docker Compose RM, it removes. So it asks, you want to remove everything? Yes. All right, so I have removed the ELK stack. So we don't have anything else running now. So we are good. Now we can get a step back because we'll download the repository here for the next exercise. So git clone, this doc-prom is the name of this project folder because it is Prometheus in Docker, so that's why. So we have the code here for the doc-prom. Now let's go into that folder. Changing these folders is very important. Like if you run the Docker Compose from outside the folder, it will fail. So always remember, whenever you clone a project, go into that folder like this and check the code is there or not. You should be always on the same folder, like wherever you have the Docker Compose for that particular project, you should be present on that particular place in the directory structure. Only then the Docker Compose command will work. So we are here now. Then you can follow the next. This is the command to launch that Prometheus Grafana cluster. So what is happening in the command? We are we are setting up two variables, like the variable of the Grafana dashboard actually. So admin user and admin password are both admin. You can put your own password if you want. And then the command docker compose d. So docker compose up minus d. And the username password, I want it as admin and admin. So it will start up all the required components. For the first time, it will take time, but for me, it did not take time because in the same machine, I had taken a class of a different batch for this Prometheus thing. So already the container images were present, so that's why it ran in a second. But when you are doing it for the first time, it will take around 10 minutes to download all the 7-8 images here. Okay, so just like we did it with the last one, it took some time to install. So this one will take some time for the first time. From the next time onwards, you will install it very fast, just like I did. So now we have these things running. Now let's see which port Grafana is running on. So we'll go to the dashboard on that port. Docker ps, and let's check Grafana is here. So it's on port 3000. So let's go to our server IP again. This is the same server. So I'm just putting 3000 here. So I'll get a dashboard for Grafana. So this Grafana automatically, it starts monitoring all the different Docker containers here. Okay. So if I want to see the Docker host dashboard, see data has started coming in. If you look for this one, after 5 minutes, you will see some more data has come in because it just started coming in here. So if I go, for example, to Docker containers now, so I can see some of the metrics are coming in for whatever Docker containers are running. But why is there no data here? This is because there is no other container running apart from the containers which comprise this Grafana and Prometheus cluster. Okay, so only their own containers are running. There is no outside container running. So we can test this out by uh, running a simple Nginx or any other image and then see it works or not. I mean, whether we are getting the metrics for that image or not. Okay. And let me tell you one more thing. Here we have a alerting manager, which we can use to send alerts also. All right. So first, let me start this one. Then I'll show you the alert thing, and then we'll be done. Okay, so what I was saying, let's run any container and then we can start monitoring that container. So what I am doing now is, since I'm going to start the Nginx container, I want to ensure that Nginx is already running. We did this some time ago, so there would be a conflict of port. So let's stop the Nginx which was running, because that is a non-container Nginx, like that is not a Docker. So I want to stop it. All right. So here you go. You don't have any more Nginx here. Now we can run a Nginx docker run minus. Okay, let's put it on the background. Then Nginx. All right, the container is running. So you can see Nginx has started running here. So now I should get some data here. You see one data point has started appearing. What is the Nginx container name? This one. Nice Lovelace. So this, you can see this one. So here you have the memory and the CPU data points coming in. So if you leave this for 5 minutes, a graph will develop for this particular container. So if you have 5-6 containers like that, then you will have a graph being created for each of these containers. Okay, so let's make it a bit interesting. Like, let's name it, for example, just imagine that this container is a Jenkins server. So we can just imagine that this is a Jenkins server. So we can name it a Jenkins server and run it, and then we start getting the metrics, and then we can emulate the failure and success of that server and try to get an alert on Slack. Okay, so this is the last thing we will be trying. Don't worry if you don't understand fully. I'm telling again, you can go through the video and make sense slowly. Like, it will make sense to you, I mean, once you go through it once again. All right, so what I'm going to do now is we have to set up those alerts and the Slack thing. So we have to kill everything and start from scratch again. Okay, so docker rm, and I remove the nginx, and docker compose stop. So it will stop everything. Then docker compose remove. Yes, so it removes everything. Okay, so now we are clean again. There is no Grafana anymore. So it throws error down. All right. So we'll make some changes and then we'll bring back our container. So what changes we'll make? Let me show you the repo once again, that when you are watching the video later on, you will understand what was being done. So our aim now is to run the same stack again, but we will have a dummy Jenkins server also, and we will try to monitor that Jenkins server and see whether that server is up or down. If it goes down or goes up, we should get an alert on Slack. Okay, so for that we have to set different things up in the alert manager, this folder. There is a script where we have to set certain things. So there's a file called config.yaml inside alert manager. Let's see what's inside. It says this can connect to a Slack server, and the Slack server will receive the alert from Prometheus on the channel name that we will define and the API URL that we will define. Okay, so this is the thing we have to do. So what is the channel name and the API URL? Let's get that configured on Slack first. Then I'll show you how the alert goes when that particular server is down. So let's open our Slack channel. So if you watch the CI/CD video, you will see about how to create a Slack account and how we did a Slack alert. So watch that part. So then you will understand about the Slack thing. So I'm going to slack.com and I'll go to my workspace. So wherever, if you are implementing it for an organization, that organization will have a Slack account. So you will go and similarly log in. So here we are. This is my Slack workspace. Okay, let it load. I'm seeing why this is slow, because the outbound network capacity, I mean, there is too much traffic going on. That's why. That's why network is slow and it takes time to load. All right, so we have our Slack channel here, and there are various channels present. For example, I want to send alerts on the alerts channel. All right. So my channel name should be alerts. So I'll go back to the code, docker prom. If I do a ls, I will see docker compose.yaml, and where is that folder? Alert manager. So I go inside alert manager. This is the same file which I was showing you on GitHub, config.yaml. Go inside it and edit that file and put the channel name. So our channel name is alerts. Okay, I get the channel name from where? From here. This is the channel name. If you don't have a channel, you can just click here and name something and add a channel. Okay, or you can use a general channel also, or any default channel which you have on Slack. Okay, so we have a channel now, and we have a channel name which we have already put on our config file. Now you click on add an app. So here it asks you which app you want to integrate with to send the alert. So this app, which allows us to send alerts, is called a webhook. So search webhook. So you will see incoming webhook. What does it do? Send data into Slack in real time. So this is what we are going to do. We are sending data into Slack. There is another one called outgoing webhook, where Slack sends data to someone else. So this is not what we are doing. We are having Prometheus send the alerts to Slack channels so that everyone is notified. So whoever is there on that group in office will be notified. So we will use incoming webhooks and click on install. So once this page loads, they will give you an option to have the various settings and have it installed. Okay, so here it says add to Slack. So I add it, I click it here. So it is trying to add this channel to Slack. Here an authentication token will appear. All right, before that, it's asking to choose a channel. So I want to post it on the alerts channel. So choose it, click here. So here it generates a token. You remember this slack.com/services was already there. So this last part has to be added to that particular URL. So if I go here, you can see it's asking for a webhook ID in the end. So that is the ID we will paste. This is for authenticating whether that particular Slack channel is ours or not. Otherwise, other people might hijack your Slack channel. Like they will post garbage things on your Slack channel if they get this number. So while generating it, you have to be, a bit secretive, because if someone else gets this, he can post things on your channel. So this one is done. Save that file. Okay, you might be thinking like what I am doing with this vi command and it is difficult. So if that happens in your case, then you can do one thing. You can directly edit it here. You will fork this repo from mine and you can use your own URL and you can edit it here and then use it. Okay, but in that case, if you are putting your Slack URL here, then make your channel a private, make your repository a private repository, because if others see your token ID, then It's not a good practice. Or you can just clone this into your Windows machine and directly do a edit instead of using VI. Okay, and then say, use that folder. Okay, so better you can create a private repo and edit it. Or if you learn VI, then nothing better than that. Like because in the Windows, I mean in the cloud servers, Linux cloud servers, you would not have a GUI. So it would be a good practice to learn about the VI editor to start the Slack channel. So start the alerting in the Slack channel. So one more step left here. Save settings. Okay, settings have been saved. Now let's go back to our workspace. So here we are, and here you can see that I have added an integration called incoming webhook. So that's fine. It automatically alerted that this is the thing going on. And now what do we do? Now we have to start up our stack. So I go back to the location where the Docker Compose file is, and let me start up Docker Compose up. All right, we have to set up those username passwords also, right? Okay, so I cancel that and I write it once again. So now it starts up all the servers once again. Now the Slack alert thing would also have gone. Okay, and it would try to check whether there is a Jenkins server or not. If there is no Jenkins, it will send an alert to our Slack channel. So if we go to our Slack channel and wait, if the integration is correct, it should send a alert here. If not, then we'll leave it here and try to investigate later on. But it runs after a while and sends alert like every minute or something, then sends you an alert. All right, so we'll see after a while. So meanwhile, let's start our Jenkins server also. Let's see what's there in the Docker. All the containers are running. That's good. And let me start a Docker container here. Docker run -name. I'm just naming it Jenkins because it's trying to monitor the Jenkins, but actually I'm running a web server. I think 2 dashes. Okay. So here we are. We have a Jenkins server running here. So you see the Jenkins server was down and we got an alert from Prometheus. Now the Jenkins server is up. We should get a healthy alert again. So our alert system is working. Apart from that, if we open our Grafana again, it should be up. And now we should be able to see the Jenkins container there. You can see Jenkins is there now. And the data is coming in. So This is only for Jenkins container, CPU and memory. So that's how these metrics will keep coming on. Like if we keep this on for 1 or 2 hours, we will have this entire thing full. All right. Or if we reduce the time, then we'll see a bigger graph. See. So if we leave it at like that, so it will start working. Meanwhile, on Slack, you will get a healthy alert after some time. When the next time the cron job runs, it will send a healthy alert that this channel has, the Jenkins is up, because we are already running the Jenkins. Okay, see, we got this alert a little late when that was up. This alert came when Jenkins was not up yet. This alert came when Jenkins was up. So that concludes the session on monitoring. We did a good job with the hands-on. So we covered ELK stack, we covered Grafana and Prometheus, and we covered a networking tool called NetData. Apart from that, we also understood what monitoring is, what are the major things that happen when that goes in when you do a proper monitoring of your systems and servers. So keep practicing, work hard on your learning. I always say that. See you in the next session. Thank you. Have a good time.